Okay, hello, welcome back to my channel. This is part 4 of the series for the Dutch F exam. And again, I don't know when exactly this exam was given, what year, what date, because this website is generating exam when you open the site. So I left the site open when I stopped the recording for the first 3 parts. So, and I still don't have a clue why the previous part 3 almost lasted for 30 minutes, but... So let's continue with the next 10 questions. The load current I, so it is mentioned I bell, and it's the load current, so belasting, varies from 100 to 300 milliamps. The maximum power dissipated by the Zener diode is... the load current. So the maximum load is dissipated by the Zener if you have the least current drawn by the load. Because with the 300 milliamps load, the voltage drop over this resistor will be bigger. So with 100 milliamps, let's get the calculator again. So 0.1 times the 25. Oh, 25 is 2.5 volts. So that would mean that with the 100 milliamps out, the Zener diode has to dissipate 7 volts or 7.5 volts to bring the voltage down from 20 to 10 volts. But I'm wondering, are we missing a graph or whatever that is showing? Or at least, if this is 10 volts, then we have to dissipate 25. So it will be 10 volts divided by 25 is 0.4, so that's 400 milliamps. But can we say that? This is another tricky question. Because I think somehow we need a graph to calculate this. Because the Zener diode will pull this part back to 10 volts. So okay, that again. So to pull this back to, okay, yeah, that's it. So to pull this back to 10 volts, there will be a current of 400 milliamps going through the resistor. Only 100 milliamps in them is going to the load. So there will be 300 milliamps going through the Zener, and then it will be so then it will be 0.3 the current through the Zener times the voltage 10 volts at 3 watts, so it's answer C. Yeah, it does make sense now. So with the least current going to the load, the voltage drop over this resistor will be enough to bring the voltage down from 20 volts to 10 volts on this point. So there will be 10 volt over the resistor, so that will be 400 milliamps, 100 milliamps going through the load, 300 milliamps going through the Zener diode, and then it's just simple math. 300 milliamps times the voltage, 10 volts, will be 3 watts. Okay, next question. Vertical antenna has a length of 10 meters. The impedance of the antenna is approximately 36 ohms. The transmission frequency is approximate. Yeah. I would say 30 megahertz. Just a simple calculation of. In Europe is a little different, a little easier because of the metric system. So then it's just 300 divided by 10 is 30 megahertz. Yeah, we'll go for that. In the circle, the value of R is halved. Ooh, I have seen this question before, at least a similar question. Then they had a switch in the in series with the R. Then they were asking what happened if the switch closed. The resistance is messing up with the Q. So R is halved, so I think it will become twice as big. Because I don't think there's any quadratic going on in the Q of a resonant circuit. Yeah, we'll go. I'll say that the bandwidth becomes bigger, so it's getting wider. 34. The following IF signal is applied to an FM detector circuit. What outputs? Signal does the detector circuit. And when I look at the waveform, it's more like an on-off. I don't see, or the image is too small, but I don't see the frequency going up here, so signal 1 is off. And the signal 4 is also off, because with this signal it would be a steady signal change. So it is an on-off signal. So I will go for signal 2. Or will it be signal 3? Yeah, we'll go for signal 2. Looks to me to be an on-off signal. This is also translated a little bit incorrectly because of Google. The transistor is switched in. Combination of GPS and GES, so this common base circuit and common emitter circuit. No, there's nothing common about the base. So I'll go for the common emitter circuit. Because, yeah, the emitter is part of the input and the output. So I'll go over the common emitter circuit. Which circuit oscillates at the resonant frequency of the LC field circuit? Ooh. Pooh, I have no clue, but my gut tells me it's Y. Or neither. No. I guess somehow this makes more sense to me because this could be a feedback loop, but it's also the LC circuit is also grounded. And here the LC circuit is between base and collector and emitter. No. Oh, Y is not. Oh yeah, I go for Y. I don't know why, but I go for Y. We'll see in the answers if I had it wrong or not. An amateur transmitter generates minimum power of harmonics by setting the output state in. No. Class A would be the best. Most of the times it will be AB, but that's more or less. So the best one is Class A. Most times it will be AB because that's kind of the most efficient. Okay, 38. How are we doing on the time? 60 minutes already. The following is dissipated in the attenuator. This first factor is attenuator and belasting is load. So we're putting 6 watts in. Attenuator is 3 dB. So we don't have a load mismatch because both of them are 75 ohms. It's a factor 2, so I will guess we dissipate 3 watts in the attenuator. Okay, move on to the next question. See if we can keep it under 20 minutes. An open power line to a transmitting antenna should radiate as little as possible. The radiation from an open power line can be reduced by I never thought about this. So how can we... I think to make the distance smaller, because I think when you make it bigger, I guess in a normal situation they have a counter effect on each other, so it doesn't radiate. So I think it is answer D, reducing the size. Because if you increase the size, then the effect of it on the lines to each other is only reduced. So I guess that gives a better opportunity to radiate. So yeah, I will stick with answer D. This characteristic relates to a diode resistance, a resonant circuit, NPN transistor. I think a diode. Resistance would be a straight line. Resonant circuit also doesn't make sense. And I would think for an NPN transistor, I think the line would be a little bit more, because this is not really an ideal working line, so I go for a diode. Okay, that was question 10 already. Just keep it under 20 minutes. So thank you for watching. We'll continue next time with the last part of the episode, and then also do the scoring. So maybe that one will take a little bit longer. Thank you for watching again. Please like and subscribe, and see you in the next episode when we also are going have a look at the grading. Thank you, 73. Bye bye.